This example comes out of section 9.3, connecting graphs and rational equations. In this first example, we're looking to solve x plus 2 over x minus 3 equals x minus 6. So this is an equation. We're looking to figure out what x equals. Might want to remind ourselves right away that x does not equal 3. So if somewhere in the end we get a solution where x equals 3, we know that that's not possible because you can't divide by 0. Now, graphically, we could definitely just graph each side of this equation and see where they intersect each other. So we'd say y1 equals x plus 2 over x minus 3. Y2 equals x minus 6, a plain old linear function. You end up with, as long as your window settings are somewhat normal, negative 10, let's say, to 10, and negative 10 to 10, what your calculator defaults to, you're going to have an asymptote at 3, something like this, and you also have a curve something roughly like this, and another curve here. And that's the first graph, and then the x minus 6 part of that is something approximately like this. And if you do second trace intersect and find your intersections, you will find two of them, and you find that x equals 2 and x also equals 8, these 2 points where these graphs intersect each other. Now, graphical solutions we've done in almost every unit so far, so I'm pretty confident that, barring some mistake of not putting brackets around or something like that, you'd be able to do that for any equation that I give you this year. But let's talk about the algebraic solution. X plus 2 over x minus 3 equals x minus 6. If I'm solving this algebraically, I'm going to multiply both sides by x minus 3, so that I end up with just x plus 2 on this side. I have x minus 6 times x minus 3 on the right hand side. Basically, again, what I did was multiply this side by x minus 3 and this side by x minus 3, so that on the left side I no longer have a denominator. So I've got x plus 2 equals x squared minus 6x minus 3x minus 9x plus 18. Now if I want to solve something like that, I make it equal to 0 and factor, so I've got x squared minus 10x plus 16 equals 0. If I can think of two numbers that add together to give me negative 10 multiply to 16, I'm happy. If not, I have to use quadratic equation. In this case, the numbers work out that I have x minus 8 times x minus 2. So the two solutions are x equals 8 and x equals 2. Neither of those is my non-permissible value, because x, remember, could equal 3, but that's fine. 2 and 8 are both acceptable answers, and they are the same answers we got when we did that question graphically.